Hello students, and welcome to another edition of Mr. Hargrove's math class, where today we're going to talk about rate of change. Please make sure that you have a pencil, paper, and a calculator with you, as we will be discussing various problems where you will find the rate of change. So let's go ahead and jump right into our learning target. The learning target for today: students will learn how to determine the rate of change from tables and graphs. Now, this is a very important learning target for this entire unit because essentially, if you can determine the rate of change in various problems, you are pretty much halfway there into knowing all that you need to know in this unit. So it's a very critical piece. The success criteria, which again lets you know that you are on track to reaching the learning target. You will know that you're successful and on track to reaching the learning target when you can determine points that can be used from a graph to create a table, use the table to determine the change in y, use the table to determine the change in x, create equivalent ratios. And remember, ratios is another way to say fraction. You could also say create equivalent fractions, where I put the change in y as the numerator and the change in x as the denominator. Simplify the ratios or the fractions to their reduced form. So here are just some basic notes. What is a constant rate of change? Well, the rate of change deals with, it's a ratio that describes how much one quantity changes with respect to another quantity. And here you're going to be dealing with x and y. So x changes and x causes y to change as well. So it remains constant from one ordered pair to the next. So how do you find the rate of change? Well, you find the rate of change, as mentioned, by creating a fraction. And that fraction includes as your numerator change in y, your denominator change in x. Now, it is very much commonly written this way, the simplified way, delta y over delta x. And in math, delta represents change. So you will frequently see me write that using that delta, or that symbol that looks like that triangular symbol. It represents change in y over change in x. Other information you need to know, it's listed here. Any situation that has a constant rate of change is going to be linear. It's going to graph a line. Your y variable depends on x. And you're going to see exactly what that means as we jump into this word problem and into the problems. But x does not depend on a value. X is independent. And you'll see what that means even in this first example right here. So I'll go ahead and I'll read it. It says, it's a fundraising example. The table shows the amount of money a booster club made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. So what we're going to do in this example is we're going to find the rate of change. We need to figure out what x is changing by and what y is changing by. And to keep things simple, I'm going to go ahead and label this column as x and this column as y, because your y variable, it represents the amount of money. So this is your dependent variable. It's dependent because it depends on the number of cars washed, which is what this column represents. This is the number of cars washed. This is how much money they made. So how do we find the rate of change? This is how. We're going to determine what is y changing by. And when you look at it, to go from 40 to 80, that is an increase of 40. To go from 80 to 120, that is an increase of 40. From 120 to 160, that is an increase of 40. Now let's look at what x is changing by. I go from 5 to 10, so that's plus 5. From 10 to 15, that is plus 5. 15 to 20, that is plus 5. Now, to determine the rate of change, this is all we do. the change in y over the change in x. So y is changing by 40, x is changing by 5, 40 over 5, now we got to simplify it. That simplifies to 8 over 1. 8 over 1 is 8. So my rate of change is $8 per card. I'm done. That is all we do to find the rate of change. That is all we do. So this is from a table, and we'll look at another example here that deals with a table, but this is all we're doing. So it says, Hero Comics prints on recycled paper. The table shows the total number of pounds of recycled paper that has been used each day during the month. Let's investigate the properties of this relationship. So we're gonna go ahead and label this column days of the month. That's gonna be X, that's gonna be Y, because your total recycled pounds depends on what day of the month you're dealing with, because it looks like every day they recycle and they collect a certain amount per day of recycling. So how much you have depends on where you are in the month. So that's why X is going to be your independent variable. That's the day of the month. So in this table, they've given us the 3rd day, the 5th day, 6th, 7th, and the 12th day. Now let's find the rate of change. Let's start with, what is our Y column changing by? And if you look here, to go from 36 to 60, that is a change of plus 24. To go from 60 to 72, that's plus 12. From 72 to 84, that's plus 12. And then from 84 to 144, that is a change of 60. So you can just find the difference between the numbers. 144 minus 84 gives me 60. 84 minus 72 gives me 12. Just find the difference between the numbers. And then as we go here, these numbers are simpler. To go from 3 to 5, plus 2, 5 to 6, plus 1, and 7 to 12, that's plus 5. Now we're going to make some ratios. Change in Y over change in X is how I'm going to determine the rate of change. Let's look at the first row. That's going to give me 24 over 2. That should be equal to 12 over 1. And the next one, that's also 12 over 1. So I'll go ahead and I'll write it. And then this one is 60 over 5. Now, all of these ratios are equivalent. 12 divided by 2, 12 divided by 1, 12 divided by 1, 60 divided by 5. They all equal the same thing. They all equal 12. So that means that the rate of change here, we're dealing with 12 pounds per day of recycled material. Remember, it is always the change in Y over the change in X. Sometimes your table will be laid down on its side. In fact, you're going to see some problems like that. But always look at what your Y column is and what your X column is. And just remember, it's always change in Y over change in X, not the opposite. Okay? So we've looked at some tables, and now we want to look at some graphs. So let's find the rate of change from this graph. It says the graph shows the number of minutes it took Kylie to run laps around the track. And we'll just pretend that she's running at a constant rate. So this is always going to be, when you're looking at a graph, this is going to be your x-axis and your y-axis, and it's always set up that way. So my dependent is going to be the number of laps, because here it depends on how much time has gone by. How much time has gone by. So let's figure out the rate of change. Now, they didn't give me a table, but what we're going to do is we're going to use this graph to make a table. And it doesn't have to be perfect, doesn't have to be pretty. just have to be able to understand it. So I'm just gonna make a few sections here, and I may not use every single one. This is gonna be my X and this is my Y. So now I just need to find some points that I can clearly see on this table. And I'm just gonna use the ones that they've already highlighted. So this point right here is 10, 5. Remember, we always start with X. So we go over to 10, go up to 5, that's that point. But I could also start right here because this does go through 0, 0. So we'll just say the first point is 0, 0, and then we'll use this one. We'll say when X is 10, Y is 5. The next point, when X is 20, Y is 10. And then when X is 30, Y is 15. So now, let's figure out the rate of change the same way we were doing. Plus 5, plus 5, plus 5. And then over here, plus 10, 0 to 10, plus 10, 10 to 20, and then from 20 to 30, that's plus 10. So to find the rate of change, it is change in Y over change in X. My Y is changing by 5. X is changing by 10. And it's that each time. So 5 over 10, that simplifies to 1/2. So the rate of change is right there. Kylie is running half a lap per minute. Half a lap per minute. So this table matches this graph. It's just another way of expressing the same information, which is also going to be a big part of this unit. You'll see that tables, graphs, word problems, that there are a number of different ways that you can reflect the same information. This unit, we'll be looking at tables, graphs, word problems, and equations. So 4 different representations of the same information. Got to be able to find the rate of change, though, in order to understand those representations. Okay, let's look at one more example. It says the graph shows the number of apples per basket at a farmer's market. So let's find the rate of change. Remember, they gave us a graph here so we can identify that this is going to be X and this is our Y axis. So the dependent variable is the total apples. The independent is going to be your number of baskets. Let's find the rate of change. So we're going to make a table. Again, it does not have to be pretty, it just has to be good enough to understand the information. I'm going to make one more column just in case. We'll label this X and this is Y. And again, it's the same information if you see this information laid on its side, because sometimes you will see the table written this way, and you can do that also. You may see something like this, X and Y. It's just another way to represent the same information. So for this problem, why don't we just use this one? It's fine, we can just use this one. We'll lay it on its side. So the first point I'll look at, when X is 0, Y is 0. We have another point right there, another point there. So I may not use them all, but I see that when X is 1, Y is 5. And then I also see that when X is 2, Y is 10. And I actually have enough points right here. So let's do, what is X changing by? And what is Y changing by? Well, X is changing by +1. Y is changing by 5. Right? So to find the rate of change, remember, it's change in Y over change in X. So I'm going to come down here and look at what Y is changing by, which is 5. X is changing by 1. 5 over 1 equals 5. So my rate of change is 5 apples per basket. And again, I wanted to show you this because again, it's the same information that we can reflect here. It's just sometimes when students see it laid on its side, they sometimes get confused. But just remember, even if they put Y at the top, X at the bottom, the rate of change is always change in Y over change in X. So just get that drilled into your head, change in Y over change in X. I'll go ahead and I'll finish out this one as well. And this one is 0, 5, 10, but you'll see same information. Rate of change is 5 apples per basket. All right, that does it for the rate of change unit. Hopefully this helps you out in your practice for finding rate of change. So again, I want to take this opportunity to thank you so much for spending time with me here on this video. Look forward to seeing you on the next lesson.